Yeah. And so because we have started late, let me just also ping in the WhatsApp that, okay, we have started the meeting. Session, fine. Okay. Okay. So, so the recording has started. Let me just share my screen and it will start. Okay, guys. So you can see my screen, right?
Yes, available.
Yeah. Okay. So, okay. Let me just go to the public sheet. I think I can have this week's. Yeah. So, so this was last week. So the previous day's session recording. Okay. So let's share it here.
So can you share it in WhatsApp group as well?
Yeah, I will share it in the WhatsApp group too. But let me just share it here once, and then I will share it in WhatsApp.
Uh, Sir,
Yeah.
can you share the previous year's assignment solutions
Yeah. So no,
if you have
so
access?
see, I have access to previous year assignments, but
Okay,
so we'll solve it week by week. So it will be kind of, so just giving you the resource, like the questions should not help, right? So we'll just also discuss the questions, that how to approach them, how to solve them. That would be the objective of these sessions. And because so some of you have mentioned that, okay, we need also revisions from the concepts that were taught in the class. So just also whenever we are, let's say, trying to solve a particular set of problems, we'll first revisit the concepts, and then based on that solve the problems. Okay.
sure, sure. Sir, it will be great if you can just put all the assignment questions at
Yeah,
least on the WhatsApp together
exactly.
so that
Yeah, so
those who are
that
at
that
a
I can
higher
do.
pace can, start solving anyway. Right?
Exactly. So that I can do. So that
Okay.
I will show you how to access. Wait, let me. Uh, this one, I guess. Yeah. So this is last year, like last session run. Okay. So I can have those assignments here. Anyway, so I'll download the assignments and make it as a zip and share it in the WhatsApp group. Okay.
That will help. That
Excuse
will
me,
help.
sir.
Yeah. Yeah. Go ahead.
Excuse me, sir.
Yeah. Go ahead.
Myself, Dipali Vishnoi. Sir, I
Mm-hmm.
would like to know that please add me in the WhatsApp group so even I can get the information.
Yeah. Exactly. So I can uh,
Uh,
share you the
my name is
WhatsApp link.
Dipali Vishnoi.
Yeah, so I can share you the invite link. You can join by that invite link. So go to the chat and see. Okay, someone has already pasted it. I have also pasted it. Uh, okay.
Uh, Good
Uh,
evening, sir.
good evening. Go ahead. If you have any
Sir, is this
queries,
the
just yeah.
yeah, sir? Is this the first doubt clearing session, or is previously something also happened like yesterday?
No,
People are saying.
yeah. So see, there will be multiple TAs in this course. Okay. So this class is introductory class for me. So this is the first session I am taking. But I guess last day, so Friday, you also have a class that is from 7 to 9, I guess. Okay. So that link I will share. So so we have a common Let me share you that sheet. See, this
But so
is
the
this is the
WhatsApp group
sheet.
is
Yeah, so this is the sheet that was shared with us to kind of fill
Hmm.
up whatever recording links we have, whatever resource folder we have in our drive. Okay, so you
Yes,
can
sir.
follow this sheet as well. Let me just see. Anyone with this link can view, copy. I'll send it in the WhatsApp chat as well. So let me just share
Yes,
it
sir.
here once.
So WhatsApp group is same now for different
Yeah,
TAs also.
exactly.
This is the only
Yes.
WhatsApp group.
For other TAs, I don't know, but today I have I
Okay.
guess someone has created a WhatsApp group. I will share
Mhm.
all the materials, all the resources, the recordings of the videos there itself, the link for the recordings and all in that
Yes, sir.
WhatsApp group. Okay, so just join that WhatsApp
Okay.
group if you are like so one thing is you can follow all the TAs. Okay, so it will be very helpful for, or let's say every TA will approach the problem in a different way, right? So it will be very
Yes.
helpful for you to kind of get a holistic understanding of the questions that will come in your exams.
Okay, sir.
Okay, so so it will be so otherwise if you have very limited amount of time, you can stick to one TA of your like, let's say whoever's teaching method you like, right? If you cannot
Okay.
attend, so if by chance if you have classes with your own work or something, then you can always
Mhm.
follow one TA. But okay, it is very much recommendable to follow both the TAs. Okay, so that you have a kind of so anyway, the both the TAs will revisit same concept, same type of problems, but they
Yes,
will
sir.
kind of give you a holistic understanding of the questions. So that and for just to clarify, your exams will be a kind of computer-based test. Okay, so you have to
Yes.
attend in your nearest TCS Ion centers. Okay,
Yes.
so
Yes, sir. Only thing we wanted is that the WhatsApp group should be common for both the TAs. Otherwise, it would be too much. Yes.
okay, so what I can do, I can just contact the other TA. Okay, and
Yes.
ask
Yes,
him
sir.
to join in the same group.
Yeah,
Yeah.
yeah. That will be very helpful, sir.
Yeah, go
Sir,
ahead, go ahead.
also an administrative question. The
Go ahead.
calculator that is going to we can use in the exam, is that
Mhm.
link available anywhere so that we practice
Yeah,
also with the
yeah. So
same calculator?
someone has shared that link
Yeah,
here.
but that is not
But
a scientific calculator. That is a normal
that will be
calculator.
available. So it's like TCS Ion calculator.
Okay.
Yeah, this will be available.
Okay.
So
So
you can see you have all the sine, cos, arcsine, arccos operations as well as log,
yeah.
exponentiation,
So
power.
metrics and all is not available.
No. So matrix, these things are only available for, let's say, like greater than 82 ms calculators, right? So it's like if you had a 100 ms calculator, then you can do matrix operations. But anyway, so this is kind of a generic calculator that you get 82 ms, similar to 82 ms. Okay,
And we
so
can't
you
take
can
our
have
own,
this.
right?
Yeah, go ahead.
We can't take our own calculator in the exam.
No. You cannot take your mobile phone or your calculator in the exam. Okay.
So please once again share the link of WhatsApp and the link which was done yesterday.
Okay. So what's is this one? And the link to follow up with all the TS and their recordings are here. So you can just, yeah. And the questions that will come can vary. So it can be MCQs. Okay. It can be little like short snippets of codes as well. Okay. So that platform, the TCS and exam platform supports both writing code as well as these MCQs. But you can be assured that there will be no kind of descriptive questions. Okay, so we'll see the assignments how they have formed it. Based on that, we can kind of narrow down which problems we should focus more, which problems we can kind of skip. Okay, So yeah, so and for accessing my YouTube channel, you can have, yeah, this is my YouTube channel. Okay, you can see that there are like last runs recordings as well. So last session I took like computing with Python. You can use this YouTube channel to follow up with the recordings. Okay, and see, I don't think that there will be any, like, there will be recordings shared from NPTL. Okay, so we'll only share you the recording and we'll share the recording to them as well. So just for your uh, like information, it's better to follow up with our YouTube channel. That would be best. Okay, because everything will be uploaded there. Then we'll share that link to NPTL. Okay. Okay, so
Okay.
someone has raised your hand or something. So please go ahead and ask if you have anything to.
Actually, I joined now. My question is, will there be any practical session like
Yeah,
programming session?
exactly. So these sessions, these like live sessions are meant for that. So we are supposed to kind of give a revision to to the concepts that were taught in the class, and then do like hands-on programming or this live example solving. Okay. So you can expect that there will be a lot of like this kind of live programming sessions.
Sir, what course is it doing in this session, sir? Because I have left the previous session.
Can you ask again?
Sir,
And
for
just
which purpose we are come here to join this meeting with this?
okay. So if someone is not asking any question, please mute yourself so that it doesn't interfere with others speaking. Okay. So what I understood from your question is what this course is about, right?
Yes, sir. Yes, sir.
Okay. So let me just give you a quick demo of the exam. So what are the things that will be taught in the class? Right. See,
So
this
can
is
we
the
also
course.
start the class?
Huh? Go ahead.
So are you starting the class now?
Yeah, I've already started. Let's just discuss some queries that you already have. So, for example, what will be covered and all, right? So, these are basic queries everybody would have. So, how the exams will be taken, these things, right? So, let's just
So this
clear
is a
them all.
query session, sir. Sir, this is a
Uh-huh.
query session or sir, this is a query session or class session?
This is the query, but it's an interaction session actually. Okay. So you have some questions on your mind, you can ask me, or like
Like
so
doubt
what I,
session.
yeah, exactly. So what I'm supposed to do is to clarify your doubts with the theory and then kind of give you a practical use case or solution or
Uh,
practical use case of those theories. That's it.
Sir, I have put
Okay.
one doubt
Sir, can you please
related
keep
to the
the
subject.
query session to the end and then straight away to start off with the lecture of today? Because this query session will go on and on and on, and ultimately we won't get any time for solving the questions and all.
Yes,
Okay.
sir. I actually
Already we
agree
have
with
been
you,
waiting
sir.
for 1.5 hours, so it's better that we start straight away to the topic.
Okay. So let me. Okay, so go ahead. So we'll first discuss the course layout. Okay, so probability theory, linear algebra, these things for mathematics. So this is the kind of recap you would have, and then we have this regression, classification problems. Okay, so let's just so for code along, we'll use Jupyter Notebook. Okay, so let me just introduce you to the platform that we will be using. Um, Yeah, just mute yourself if you are not asking a query. Oh, sorry, you have already have a material folder. Yeah. So I will use this platform kind of to demo you uh, code, like to code along with you. Okay. So you can also have this kind of like server instance installed in your local machine so that you can kind of follow along. So what is the benefit of this? We can, let's say we can run something and like without company, without, let's say, getting the output at once, you can kind of break the outputs and see whatever output is coming intermediately. Okay. So let's say if I want to have two variables, A and B, right? And then I want to see their sum, I can just do this. Okay. So every cell would act as a code block, and they're kind of the information that we have here would persist in the next cell. So for example, if I want to see what is A here, I can see. So this is the best way, or kind of best intuitive way to do data science code along. Okay, so that you can see intermediate outputs and verify whether you are doing it correctly. So okay, so first we'll start with let's say for this class we'll start with basic concepts of Python. For example, how we can represent a matrix. For example, let's say this theory, right? How we can do linear algebra things on Python. Based on that, we can build, let's say, regression, classification, those concepts. So because regression, classifications, all those things required basic linear algebra. That's it. Okay. So we'll see how to do linear algebra stuff on Python. And if you have any good doubts, so how to represent, let's say, a transpose of a matrix, let's say how to multiply, how to subtract, you can ask me immediately by unmuting. So, so the library we'll be using, and I presume that like most of you already are familiar with Python. So if you are not, just see how basic data types would work. So I can share you those resources for let's say for learning basic Python. If you are not aware of it, like let me just like you can just ping me in the WhatsApp group. So okay, share me these resources as well. So let's just see what we will use for handling matrices. Okay, so we'll use a library called NumPy.
Excuse me, can you share the WhatsApp group link once more?
Oh yeah, right. So can any one of the participants share? Right? Yeah, it's already shared.
You continue, we will share.
Yeah. Okay.
Thank you.
Yeah. So so we'll use a library called NumPy. So NumPy is for numerical Python. Okay, that's the full abbreviation of it. So it provides us a good way to represent matrices. Let's say do matrix operations. Uh, or anything you like with matrices, you can do it in Python with NumPy very easily. So you don't have to like let's say write your own algorithm to multiply, to subtract and all. Okay. So how to represent a matrix? Let's say I want to represent a matrix 1, 2, 3, then 8, 9, 12, and a 3 cross 3 matrix for now. Let's say 8, or let's say 4, 2, 1.
Will this tool be available in the exam, the Jupyter notebook?
No. You have
Okay.
to write it in a like text editor. Okay. So this is for your understanding that okay, what are the immediate or intermediate outputs that were like computed while you are, let's say, doing a matrix multiplication, right? But for exam, you will not have access to this type of an interface. You would have access to a code like text editor. Okay. For example, whatever you
Sir,
have
for
in HackerRank.
So for practicing, should we use Jupyter or Python, I don't think.
No, you can use Jupyter. So see, so it will not be like you whatever you can do it in Python IDE is doable in Jupyter. Okay, so the only thing is you can see intermediate outputs. Okay, without printing them. So in Jupyter, in Python IDE also you can print intermediate outputs by putting up a print statement. But in Jupyter Notebook, you can easily kind of see whatever is the intermediate output. Let's say if I want to see A, then I can just, yeah, okay, okay, kind of more tuned according to our needs. Okay, so let's say this is the matrix 1. So this is how a matrix is represented, and then you have to cast it, typecast it. Let's just format it properly. Okay. And then you have to format it by writing np dot array. You can write array or np dot matrix, both would work. Okay, so because array is kind of a generic type. Okay, so you can do matrix multiplication with arrays too, but there are a lot of matrix specific operations, for example transpose, inverse. Okay, these things you cannot do with arrays. So if you are working with matrix, it's better to cast it as a matrix. But anyway, in multiple things, for example, matrix multiplication, subtraction, everything is also available for arrays. Okay. So this is how you define a matrix in NumPy. And let's define another.
Sir, I have one question, sir. Sir, if I have confused in some question in a segment, so then I asked here, I able to get my doubt here.
Yeah. You can always ask your questions about the assignments here. Okay. You just keep track of those
Thank you, sir.
doubts you have. Okay. So let's just randomly change some value. Go ahead. Yeah, go ahead.
Sir, I have
Whatever
one
you.
doubt.
Yeah.
Sir, the final exam would be objective in nature or descriptive?
It will be not
A mix of
descriptive.
both.
It will be kind of, let's say,
Yes.
objective questions for let's say testing the concepts, and then some code along. So some code snippets will be there to, let's say, predict the output, or what we will do in these scenarios. This kind of small. So most of it will be MCQ. Okay, and some will be short code snippets. So we'll discuss them. We'll discuss them after you have some background on how to do matrix multiplication and everything with Python. Okay.
Yes.
So let's see. This is matrix 1. This is matrix 2. Okay. So what are the operations that are valid for matrices? So what is add, right? Then subtract, then multiply, then dot product, then
Inverse.
yeah, inverse, transpose. These are kind of most of the operations are these, right? So please let me know if you have any other operations in mind. So now eigenvalue, eigenvector is kind of not operation, it's kind of a property of the matrix, right?
Okay, sir.
Yeah, so it's like, what is eigenvalue? So whenever if you are multiplying a matrix to a vector, if the vector only elongates, right? And that factor is called eigenvalue, and whatever vector it is the eigenvector, right?
Right.
So it's kind of a property of a matrix, not something that you operate on a matrix. So these are kind of the overall operations that are available for matrices, right? And we'll see how to do them one by one. Let's add first. Okay. So matrix 1 plus matrix 2. This would work. See, and what is the logic to add two matrices? Every element should be added to the like same like counter element, right? So 1 1 should add to 1 1. Element 3 3 should add to element 3 3, right? So this is, let's just check. So 1 10 11, last one 1 and 1 2. So everything kind of like both matrices have each entry added according to their position, right? So this is how you add two matrices. You can also use, so sometimes this method is also used, np.add, comma. Okay, so both are interchangeable. So you can use any of them, matrix 1 plus matrix 2, or add this. Okay? Both will have the same impact. Yeah. Now subtract, you can use the minus operator, or you can use this subtract operators, or the np.subtract. Okay.
Sir, I am not able to solve most of the questions of assignment 1. Could you iterate through the questions?
Assignment 1. So let me. Okay, so can you share me the assignment 1? Let me. I have not logged in. Let's just log in. Yeah, just share me the photo or something in the chat. Let me just log in by then. I'll solve this issue. Wait. You just share me the snippets that you are facing problem with. We'll go back to them a bit later. Let me just finish up this concept first. Now add, subtract, now multiply, right? So there are two types of multiplication for matrices. One is this cross product and one is dot product, right? So dot product means every element should be multiplied with the corresponding element. So just like add and subtract, whereas multiply, you already know that every row vector will be multiplied with every column vector and create an element, right? Dot product with the column vector and create element. For example, row 1 and column 1 would create element 1 1 in the resultant matrix. Okay, so to do that, we can use NumPy. So multiply matrix 1, matrix 2. This will create, see, this is actually one-to-one multiplication. So this is actually dot product. Dot product. And how you can represent it in, let's say, normal mathematical notation? Matrix 1 times matrix 2. So no, it's a sorry. So to do dot product, you have to use this multiply operator. Okay. But for cross product, you can use this star and at the rate interchangeably. I was just confused a bit. So to use dot product, you have to use multiply np dot multiply. But to do cross product, you can use np dot matmul. There are three options. So this would give you cross product, or you can also use matrix 1 times matrix 2. This would also give you the same answer. Another method, so these are used interchangeably. So whenever you found, so for example, let's say in your exam, a code snippet comes with matrix 1 at the date matrix 2, right? So in that case, you have to think that, okay, it's a cross product. Okay. So these three methods means the same thing. It's a cross product or matrix multiplication. Okay. Cross product would be, yeah, go ahead.
So what is the difference between NP multiply and NP dot mat mul, sir?
Yeah, so it's a dot product. So dot product means the matrices, all the corresponding elements will be multiplied and stored in the new matrix. That's the dot product. Okay, for example, 1 and 10 would multiply and give you 10, right? Then 2 and 2 will multiply and give you 4. That's the dot product. So that means every element should be multiplied with the corresponding element only, right? But for matrix multiplication, the point is that your first row will be multiplied with the first column. That would create 150. For example, let's see first row. So 1 times 10, 10, 2 times 7, 14, 10 plus 14, 3 times 42. So what is the resultant? 1 times 10 plus 2 times 7 plus 3 times 42. 150, right? So that creates the first element.
Yes, sir. Thank you, sir.
Oh, good. So these are
Sir,
the,
can you please repeat the three methods which you just told about for cross product?
yeah. So see, it's, so I will also share this code along whatever I'm like, let's say scribing here. I will share the notebook with you so that you can, so this is for week 1. Okay. So see, you can have three variants for cross product. One is this matmul, okay. One is this star product. This star product also means cross product, okay. And then the last one is this at the date. So matrix 1 at the date matrix 2. This also means the cross product, okay. But for dot product, we have to use this np dot multiply. So np dot multiply only means dot product. Otherwise, for cross product, you can have star or at the rate or matmul. Okay. Now dot up to product we have done it correctly. Now inverse and transpose. So let's go with transpose first. Matrix 1 dot transpose. And see, knowing these different options are important because whenever a code snippet would come, there can be multiple ways a particular code can be done with multiple. Say, for example, I can use star, I can use at the date. So knowing them beforehand would be very much useful. Okay. For example, transpose has two options. You can use two type of kind of conventions to create to compute transpose. One is this matrix 1 dot transpose. It creates this transpose. Okay. So for example, this is the matrix, it's just transposed it. Okay. I can also use capital T. What we use mathematically, right? So to represent a matrix transpose, what we do? We use, let's say A is a matrix, we use A to the power T to represent a transpose, right? So similarly, for in Python, we can use dot T. Okay. So we can use dot T to say have the same transpose. Okay. So yeah. So we can compute, oh sorry, matrix 1 dot transpose similarity, right? Now how about inverse? And see, by in Jupyter Notebook, if you want to explore what are the operations that are available on this data structure, right? This matrix data structure, you can just do dot and then tab. You'll have all the possible operations of this. Okay. So dot product can be also this dot operation. Okay. So this is the dot string. Wait. Matrix. So dot. You can also represent the same thing with this. Matrix dot matrix 2 means the same thing, the matmul. Okay. Now for inverse,
Sir, how is the cross product and matrix
yeah, that's the
come to
kind
the
of,
same?
yeah, that's the kind of naming convention they have used. So to matrix dot product is also represent, cross product is also represent as matrix 1 dot dot matrix 2. Okay. Only this, so this is actually element, not dot product. You can say it as a element wise multiplication. Okay. Element wise, element wise
Will we
multiplication.
be able to execute the program in exam, or we just have to complete it and submit?
No, you will be kind of able to cross check it with multiple test cases. So there will be multiple test cases, and you have options to see how many test cases you have passed.
Okay, but the program we will not be able to execute.
No, the program will be executed. Then only you can see how many test
Okay.
cases were passed, right?
Okay, sure.
No, that's not an issue. So see, this dot product, we kind of know that dot product is element-wise multiplication, right? So that's what happens for vectors too. So dot product between two vectors means every element will be multiplied with its corresponding element and then summed, right? But for matrices, it's called element-wise multiplication. It is represented by this multiply method. But other than that, every other operations you can do, let's say for star, at the rate, or dot, everything would represent a cross product. Okay. So just for your uh, ease of understanding during the exam. For example, if a matrix dot matrix 2 is used in your code, that means it's a matrix multiplication, not a element wise multiplication. Okay. So we know it. We refer to it by dot, but anyway, it's kind of an element wise multiplication or multiply. Now to compute inverse, you can use this matrix 1 dot I. Okay. Another method is
Sir, will you share these notes in the WhatsApp group, sir?
yeah, I'll share this. So what we are supposed to do is we are supposed to uh, put everything in our drive folder, and then I will share you the drive link. Where is it?
Sir, till that, sir, that test cases, etc., that is an HackerLang tool. Is that is there in NPTEL or something else?
No, it will be that TCS Ion tool.
Okay,
Okay.
TCS Ion. Okay, it will be a TCS Ion tool. Okay, got it.
So in P linear inverse, so I can pass matrix 1. It will create the kind of same inverse. Okay. So you can use this matrix dot I to compute inverse, or use NumPy linear alg inverse matrix 1. Okay. So this is how you compute uh, these operations with matrices. Now let's see, for example, let's say I have to uh, solve a set of equations. For example, three unknown variables, three equations, right? Let's just write them or take them from web. Three equation system. Yeah, we can just use these three. So okay. So let's just solve this. Okay. See how we can solve it in Python. Three variable systems. Okay. Now our variable the equations are x plus 2y minus z is equal to minus 4 minus 2x plus 4y minus z is equal to 6, 2x plus 2y plus 3z is equal to 1. So these are our kind of three equations that we have to solve. Now we have to find for, let me, it's a markdown. Okay. Now what are the corresponding matrices we can write? So you remember this AX equal to B form, right? For solving matrices. Now X would be A inverse, let's say A minus 1, A to the power minus 1. Right? This is represented as A inverse in mathematics. and then B, right? And for A, if you write A inverse time A, it will be an identity, right? So we solve X is equal to A inverse B, right? So you will do the same thing here as well.
Sir,
And
can you repeat it?
this is a matrix multiplication. Yeah, go ahead. What was your doubt?
Can you please
I didn't hear you properly. Can you just
can
repeat
you
once?
repeat it?
Okay. So see, we are trying to solve a 3 variable system with the things that we have learned so far, that matrix multiplication, subtraction, inversion, transpose, all this. Okay. So from mathematics, what we know that a kind of system of linear equations can be represented by ax equal to b, this form, right? This matrix form. Now, to solve x is the vector for unknown variables. Okay, so to solve x, we can just multiply both side of the equation. Let me just like expand it. A to the power minus 1 a x is equal to a to the power minus 1 b, right? We can just multiply both side with the inverse of a. Now, if I just consider this part, right? Only this part translates to identity. So if I am multiplying a matrix with its inverse, it will be an identity matrix, right? The resultant would be an identity. Now, if I just let's say put this as identity, then only the unknown variable vector is equal to ix, means the x only. I means for I in matrices it means 1. Okay, identity. So x is equal to A inverse B. This is how you solve a system of linear equations. Now, from these equations to write A and B, we'll see how to write A and B. Okay, it's very easy. So if you remember your it's also in the 12th math syllabus. So you put all the coefficients in a row. For all the equations, you put the coefficients in a row. So the first equation, it will be 1, 2, minus 1, right? Now, for the second equation, it will be minus 2, 4, minus 1. The third equation, it will be 2, 2, 2, and 3. So this is how you write the matrix A. A is equal to this. Okay, and B is equal to what? B is a column vector of 4. So this is how you write a column vector. Okay, 6
So isn't it
and
minus 4?
minus 4. Oh, this is minus 4. Sorry, yeah, minus 4. Right, B. So B is this. And just okay. Now to make them as NumPy matrices, what we have to do, what we did before, right? We have to kind of surround them with this matrix keyword. So we can just do np dot matrix, put the brackets, put the data within the brackets. Same here as well. So matrix done. So we have the A and B matrices, and it's very easy to put, right? So all the rows will be corresponding coefficients for the equations, and the B would be the column vector for the these coefficients. So the value that is in the right side of the equation. Okay. So now
Can you please close the other tabs, sir?
this one. Okay. Let me, if it is not visible properly, I can zoom in. Actually, Now you can see, right?
Yes, sir.
Okay.
Thank you.
Yeah. So now we have to compute x, right? So what we have to do, we have to get the inverse, A inverse first, right? This is what we have to compute first. So A inverse would be, as per our learning before, it is matrix A dot I. That would be A inverse. Or we can use np dot
Excuse me.
linear L dot inv. This as well.
Sir, why minus
Yeah. Like,
why are you one?
yeah. Go. If you have any doubt, can you please ask properly? So I was unable to hear.
Like why are you minus one?
So see, -1 means it's an inverse of a matrix. So this is mathematical notation. Not by in code you represent it as A dot I inverse. Okay. So in mathematics you represent a inverse of a matrix as A to the power -1. For example, in transpose you represent A to the power T. Okay. So just like this. Yeah, like this. Okay. A to the power -1. So for Python, I'm just using this as a to mention that this cell computes inverse. Okay. So this is the inverse of the matrix A. And now this is the matrix multiplication. So you have to multiply this.
Excuse me, sir.
Yeah.
Cannot we directly find the determinant value of A and just divide the matrix with that? That is also one way to find the inverse, na?
No, inverse you can only find by, so to find inverse you have to also know the determinant, you have to also know the adjoint of the matrix, right? So
Yeah, adjoint of
yeah,
matrix. Yes.
yeah. So the adjoint and the determinant, everything is computed with A dot I. So A dot I compute the adjoint
Okay.
and divide the whole matrix with the determinant of A. Okay.
Oh, okay, sir.
Okay. So yeah, so this is the inverse of the matrix, and then I multiply with B. So that gives me the values of x, y, and z. Okay. So these are actually x, y, and z. X is -3, y is 0.5, and z is 2. And let's verify it once. For example, if I put the values here, see whether it comes to -4 or not, right? So x would be -3, y would be times 0.5, and z would be 2. -4, right? Same as this equation. Let's see whether it satisfies the second equation, then we'll move on to the next question. So 2 times -3, 4 times 0.5 times 2. It should come to 6. Yeah, 6. So that means x is equal to this, and the matrix S, the vector x would be a column vector where x is represented here, y is represented, z is represented here. Right. So this is how you solve a system of 3 linear equations. Okay. Okay. Now let's see what are the, so these are for your linear algebra part. Okay. To do linear algebra in Python, you can use this NumPy library, and it can have, like, it can provide it with easy computation of these multiplications or inverse and all these. Okay. Now, how would you represent data in terms of a matrix? Okay. For example, or let's say how data is represented at matrices or 2D arrays. For example, let's go and see with iris dataset. Okay. Or we can actually, for before going to iris, because iris is kind of a classification dataset, we can try and create a synthetic regression dataset and see how we can do regression. Okay, so regression topic is how to represent data in terms of matrix. Let's say I have it like, let's say by some
Yes.
mean I know this. Go ahead.
So can you please explain once again how we got X, sir?
Yeah. So yeah. So this is how you so there are three equations, right? Three linear equations that intersect each other at a point. Okay. Now that whole system can be represented in terms of matrix as Ax equal to B, where A is represented as the coefficient matrix, B is represented as the this whatever is the right side, right? This vector, column
Yes.
vector, and then we can just use A inverse B. So X is equal to A inverse B, right? So to compute A inverse, I can use A dot I times B. That would give me the X unknown variable vector, or wherever the three systems, the three linear equations intersect with each other. That's what you get by A inverse B. And that matrix is this. So X will be represented as -3, Y will be represented at 5, and 2 will be represented at, sorry, Z will be represented as 2.
Sir,
Okay.
can you tell me why we have calculated -3 plus 2 into 0.5 minus 2?
Oh, so this is to verify whether the values are actually satisfying the equations or not. So we have these equations with us, right? So whatever solution we have should kind of satisfy these equations,
What's
right?
the value
Okay,
of I,
sir.
sir?
Okay.
You got
What
it?
is the value of I, sir?
Value of I. So see, this is inverse. How you compute inverse? This one. You can compute inverse of a matrix by dot I, or you can compute it like np dot linear inverse matrix 1. So instead of putting in A dot I can use this also. Just, yeah, I can use this also. Now it is more clear, right? So np linear inverse A times B. Okay. It will give me the same result. Same, -3.52. Let's just satisfy all the equations and see.
No, sir, it's okay. Got it.
Just see. Just to keep track in your resources, we just put every equation here. Yeah. Okay. Now let's see how to represent data first. Okay. So for example, if I have a system, let's say X. So let's just go with a like very basic system. Y is equal to mx plus c. Okay, it's a kind of
Straight line.
a straight line that intersects the y-axis at c, and it has a slope of m, right? So this is actually the basic equation for regression. So for whenever you are doing a regression, the best thing you can do is to regress this mx plus c equation. Okay, so you will try to simulate this data. For example, let's just have some xy criteria. So for example, let's assume that x varies from -1 to 1, y varies from, let's just go with little bit higher values, 1 to 10. Y varies
Sir, can you
from,
please explain what is regression? Actually,
yeah, yeah, but I'll just explain the system once, and then I'll show what is regression. Okay. Okay. So this is uh, and put m is equal to, let's say, 0.5, and c is equal to, sorry, c is equal to, let's say, 2. Okay. Now if this is the system, uh, now what would happen if I have x varying from 0 to 10, then how the y would vary? That's our question, right? So if I know that I have some input x that varies from 0 to 1, how my output y would vary depending on my slope and the intersect of y, right? So let's just create x axis first. So x axis would be np dot, see these functions are important. Linspace. Linspace means linearly spaced values. Okay. So what it takes as parameters, it takes start, stop, and the number of points you want in between. So to create a x-axis, what I can do, so I already mentioned that the ranges for x is 0 to 10, right? Now I can have
Sir,
the
sorry to
x-axis.
disturb, but a small doubt, sir. For regression, we need to use y is equal to mx plus c formula, sir.
Yeah. So so regression means you are trying to approach a real value. Okay. So see the basic difference between classification and regression, right? This is two tasks that is heavily like studied in machine learning literature, right? Regression and classification. So what is the basic difference is regression, you are trying to chase a real value. For example, what is my uh, let's say blood pressure now, right? Or what is my car's current selling prices? These are real values. So whenever you are chasing a real value, uh, that is a regression problem. And let's say whenever you are trying to chase a category, for example, whether I should buy this car or not, this is a binary category, right? Whether I should buy or not buy. Or let's say which flower I should buy or which cake I should buy. So these are like finite categories that are that we can choose from, right? So I can buy, let's say I can choose from 10 different cakes, or I can choose from 3 different flowers, right? So based on this thing that whether you are trying to chase a real value or whether you are trying to choose from a set of these things, set of choices, you can classify the problem as a regression or a classification. Okay. So, so the first thing we'll see how to regress this mx plus c equation, because it's the most basic equation you can have. So based on a value, whether I can predict or whether I can calculate the, let's say the target value y. Okay. So let's say x-axis is 0 to 10, and there are how many points you have within 0 to 10. Let's say I have 100 points. So that means everything will be spaced in a length of 100. So all the points would look like this thing.
Sir,
0 to 10, 100 points.
sir, I have a doubt.
Well, yeah, go ahead.
Sir, could you please explain what is linspace?
Yeah, linspace means linear spacing. So you have a linearly spaced 100 points between 0 to 10.
Sir, are they random values?
No. They are not random values. So that's what linspace means. Linspace means it's linearly spaced. So to get random values with Python, you can use np.random.random. Okay. But linspace means it is linearly spaced. So for example, if I want 10 values, how it would be.
So you mean it's evenly spaced? Distance equal?
Linearly
Okay,
spaced.
sir. Okay.
Yeah. So for example, if I for 0 to 10, if I want 11 values, it will be 1 to 10. 0 to 10.
Yes, sir. Okay.
And the catch is for linear spacing, the start and stop both are included in the output. So for some operations, you will see that the ending value is excluded. For example, if you have already know Python, that you can relate that range operation doesn't. Let's just fast it to list.
Sir, can the start value be negative?
Yeah, you can have start value as negative. There are no such restrictions as negative or positive. Yeah, so for linear space, you can have negative starting values too. So see, for range operation, like 0 to 10, it doesn't include 10, right? But for linear space, it includes the 10. So the ending value also gets included in the output array. Okay, so
Okay,
this is one thing to remember about lean space. So let's just go with 100 values for now.
Can
So
we
this
use?
is
Can we make the values appear backwards? For example, from 10 to 0, 100 values.
yeah. So you can have into 0, but or actually here I guess you have to return step. Return step.
Hey, this guy, and 1 minute to go. Someone's phone out.
Now you have to pass this return step equal to true. Okay.
Okay.
Yeah.
Okay,
So
sir.
this is how you let the this lean space function know that okay, we have to go from a higher value to a lower value. If you didn't mention it, then also it does. Okay. But anyway, oh wait, to just read the dot string once what this return value is. Start, stop. Anyway, so if you don't mention it, it also does the same thing. Not a problem. So it can do from 0 to 10 as well as from 10 to 0. Okay. Red values, yeah. Anyway, so it takes the starting point, it space, let's say n points from start to end, given this n value as input. Okay. So this is how you
So
create a
can you please repeat what did red step do?
So red step is actually step sample. Okay. So return step, yeah, I can read it from here. So I just misinterpreted something. So if true, return samples, comma step, where step is the spacing between samples. So it actually returns you this step is equal to true. What is the sample? Is it -1 or -2? See here the step size is 0.00000 this. Okay, let's put it as 11. Now see the step size is 1. So that's what it returns. Return step. It is stepping at a 1 step. Okay. Now if I am going from 0 to 10 to 0, the step is -1. So that's what it is returning. So if you mention that return step, I want that value, it gives you the step that is taking from the start value to the end value by consecutive steps. So the next value would be attained by taking this -1 step from 10 to -1 and then 9. Okay. You take -1 step from 10, you get reach to 9. You take -1 step from 8, from 9 you reach 8. That's what this value returns. I mentioning if you mention it as false, it will not get returned. That's it. Okay. So for some computation, you also need this return step. So for those cases, you can mention it as true. Anyway, so let's just stick to this. Now this is the x-axis. Now M and C I already know. M plus C. M is not defined. Okay. It run this. So this is known as Y, or my target variable Y. Right. Let's just plot it. So to plot, and we'll see how to plot, let's say, graphs for better understanding and everything, like subsequently. So for example, it's not always recommended to learn all the plotting at once. You can learn whichever plot you required whenever you are, let's say, doing something. Okay, that would stay with you longer instead of learning everything at once. So we'll see how to do line plot now. Just do plt.plot. So you import this library called matplotlib. And if you want to see what is the graph between x and y, right? So what we have at our hand now, x is a x-axis. All the points that are available on the x, and y is all the points that are available on the y. So if I want to plot them, I can see the this y equal to mx plus c equation. Okay? So x and y, I need this plot. So this is the graph. Okay, so regression is when I have this x value with me, I want to predict the y value, and y value is a real number. Okay, now this is what regression means. And how do you, let's say, like, what do you mean by regression problem? So that's what is learned by machine learning actually. So the problem of regression problem is to find out the m and the c from data sampled from x and y. So this is a regression problem, formally defined as this. So if I want to find this m and c from not all the values, so I don't have all the values of x and y, I have some samples. Okay. For example, I can have 5 samples of x and y, x and corresponding y, 5 pairs. For example, x1, x2, sorry, x1, y1, 2, x5, y5. And from these data, so this is represented as data. Okay. And from this data, I want to find what is my expected value of m and expected value of c. Okay. So that whenever someone, so what is the benefit of this? So what is the kind of intent to do this? So the data is coming from this ground truth equation, right? So this y equal to mx plus c. This is our ground truth. Right? But we don't have all possible data points. We have some 5 samples or so, right? Now we want to estimate what is this m and what is this c. That's what we are trying to estimate. Now what we intend to do with this, let's say I have some estimate m est. This is estimated m. For example, I can have, so the ground truth m and c is 0.5 and 2, right? Now, so the ground truth is 0.5 and 2. So with these 5 pairs of x and y, let's say I estimated m to be 0.32. Okay. And so I will see how to estimate these values later on. And C to be, so this class will kind of focus on what are the problems we will be tackling, and like basic concept like what is error, what is like this problem regression, classification and all. Okay. So let's say we estimated m to be 0.32 with only these 5 values. Is what in our hand we have 100 such pairs, but we only use, or we have access to only 5 values. With that, we estimated m to be 0.32 and c to be, let's say, 1.6 or something. Okay.
Can we also get the value of m using m coefficient, something like that, intercept?
CEST.
Option?
Yeah. So I'm saying that let's say with 5 of these samples, we've estimated m and we have estimated c. So even if our ground truth equation is this, but we came up with regression. So this is what regression means. We came up with the equation y estimate is equal to m estimate times x. X we already have, like x is the data that is accessible to us. Okay. So EST. This is what we came up with. So this is the regression output.
Sir,
Yeah, go ahead.
sir, is this another method to find a solution besides KNN algorithm, sir?
Find what?
KNN algorithm, sir.
Yeah, so KNN is for classification. Okay, so KNN is used for classification. So just to quickly summarize it, KNN looks for example, I have a bunch of apples and a bunch of, let's say, oranges. Now, if I want to see what is like, let's say if I want to classify an apple, I will see its nearby object. So I'll go to an apple, see what are the nearby objects. It's apple, 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 apple. That means it's an apple. Okay. And if I, let's say, go and pick up an orange, its nearby things are orange, orange, orange. So I will mention it as orange. That's what KNN means, right? So it's a classification problem. So it's not a regression problem. Yeah, go ahead.
Sir, on the estimation that you mentioned, M and C you estimated, right? So just to clarify that is in the week 1 class where we have computed the beta coefficients. I just pasted the formula on the chat. That is the same thing.
Exactly. This x inverse xi. Yeah, exactly. So we'll use this formula to estimate it.
Sure.
We'll just wait a bit. So this is to just formally define what is a
This is
regression.
not the value of m according to it is on estimated value.
Okay. So let's say this is the regression output, right? Now, y estimated is what? Is 0.32 times x plus 1.6. This is what y estimated is, right? Now, let's plot it side by side now. This is the ground truth, or you can label it as GT, and we have the estimated y, right? Regressed from 5 samples of x and y. So you can just plt dot put legend. Yeah. So see, this is what ground truth looks like, and this is what we came up with, right? Which is being regressed from x as y estimated. So what is this? This in between whatever we are missing, right? This is called error. Okay. So by regression methods, we are trying to eliminate this error. So if this in between, whatever is in between, if I want to minimize it, right? If I just minimize it to a minimum, right? Let's say make it as 0. So my estimated will be as close to the ground truth. So that is my whole objective of a regression. So that I minimize this difference between the ground truth and regression as much as possible. So that's what this formula means, right? This formula. So it's been, I guess, derived in the class, right? In the class video.
Yes, sir. It is derived in the class. Yeah.
Exactly. So in this formula is x inverse x transpose y. Yeah. So for example, let's just take 5 random values from the whole x and y. So we'll take 5 values only. Okay. So x we have this whole 100 values, and for y we have this whole other 100 values. We will not use the whole value. We will only use 5 random values. Okay. So to choose 5 random values from x, we can use np dot random dot choice, or we
Hello.
can use. Yeah, go ahead.
I have a little doubt. What is the basic difference between error and bias?
Error and bias, right? So bias is this is called bias, the y intersect. Okay, so let's say if my if this is 30, right? See, this is what is bias. So bias is actually bias is actually a responsible variable for error. So bias creates error. Okay. So two things create error. One is this slope, whatever you are computing the slope with, and the second one is this bias. So bias and slope both create this overall error. So you want to tune the bias so that my overall error like reduced. Okay. So let's if I compute as 1.8, which is very close to 2, then the initial error will be very less. Okay. And then because of the slope, the error will increase over time. Or over high x values. That's it. So bias
Sir, can you
means
please
go ahead.
explain how you got this plot, sir?
Yeah. So we have kind of assume that this estimated slope and intersect are 0.32 and 1.6. That's what we are supposed to do in a regression problem. To find this y equal to mx plus c, we want to estimate this m and c from samples of x and y. So we defined it as, let's say I have 5 samples of x and y, and I want to estimate m and c, which is, I know that it is 0.5 and 2. But with the whole data, maybe I can find x and c, m and c, but I am only using 5 samples, right? So it gives me estimated m and c with some error. So we assume that it is 0.32 instead of 0.5 and 1.6 instead of 2. Okay. So for that case, we have seen, okay, y estimated is this one, regressed, and ground truth is x and y equal to mx plus c, that's 0.5 into x plus c. So that's how we have this ground truth curve that we want to reach, and we have this regressed curve, which is estimated from only 5 samples. Okay, now this we assume, right? But let's see how it works in action. So you remember this equation from the class, right? You remember this equation that was derived in the class. So we'll try to use this equation to kind of estimate m and c from the 5 samples of the actual data. Okay. So this is x, sorry, this is x and this is y. I want to sample only 5 data points, not the whole. So why this sampling notion come? Let's say I want to, for example, one good example would be this uh, foot size and blood pressure. Okay, so there can be a correlation between foot size and blood pressure. Okay, so if I want to collect all possible data points, which we have here at this point from 0 to 10, we have lot of data points at a granularity of let's say 0.0001. Okay, sorry 0.101010. This is the granularity. So let's say if I want to collect data for foot size and blood pressure, I can collect a lot of data, right? But it is not feasible to collect millions and billions of people's this statistic, blood pressure and foot size, right? So what I will do, I will sample randomly. So I will sample, for example, in India, I can collect this data for 2 people in every state. Okay. So that would give me a sample. So from that sample data, if I can estimate the true graph, so that's what we are trying to do. So we have this whole data. We will not use the whole data. We will use only 5 samples. Okay. And based on that,
So from random samples, we are trying to get the original value of MMC.
exactly. So we are trying to reach this m equal to 0.5 and c equal to 2. So we have seen that, okay, if I miss, like if I don't estimate it properly, there is a margin of error, right? So this is the whole error in between. This is the ground truth, this is a regressed curve. So there is a whole lot of error there if I don't estimate them properly. So how to estimate them properly with only 5 samples, we will see. So I guess you remember this equation. We'll use that equation only. Okay. So let's just choose 5x. Yeah, let's just choose 5 x and y first. So see, so if I have a lot of data, I can randomly pick 5 indices. Okay, 5 indices. So np.random dot rand int. I have 100 values, so I can choose from 0 to 100 indices. So these are indices, not values. Okay, and I want to have only five indices. So these are the indices that were chosen randomly. So I can use the values which are available on these indices. Okay, 96, 68, 19, 7, and 78. Okay, so so these are chosen INDEX, chosen index for my sample, for my data sample. Now X, so this is how you
Hello.
X array,
Sir,
okay?
I'm audible, sir.
Yeah, you are audible. Go ahead.
Sir, if I want to leave it session now, sir, I can leave it because I am not at present. I am out of station, sir, so I am
Yeah,
not able to attend.
okay,
I am,
go ahead. If you have any
sir,
works,
sir, there is, yes, sir.
yeah. So see, these video recordings will be available on YouTube. I'll share you the video recordings in
Yes, sir, yes, sir, yes, sir, yes, sir.
WhatsApp.
Sir,
Yeah.
there is any attendance link criteria or something like that?
No. The attendance will be recorded in the meet itself. Okay. So see, it's the main idea is you have to like learn how to use those tools in practice. Okay, that's it. So if you so today's class was late because I was stuck in traffic. So just
Yes, sir, yes, sir,
up
yes,
with
sir.
one
Time
day or
ever.
2 days, you'll be fine. Okay.
Okay, sir, thanks.
Go ahead. If you have any work to do, you can just leave. Okay. Thank you. Okay. So this is how you choose. This is how you choose five values from X array. Okay. So chosen index, that means from 0 to 100th index, I have only chosen these values. Yeah, these are the values that were chosen. From X, I have these values, and from Y, I have these values. So this is my entire data set at this point. I don't have access to the entire X and Y array. Okay, only five values. Now let's see how to estimate M and C with this equation. Okay. So the equation should be written as this uh, let's say weight
Sir, small
is
doubt,
equal.
sir.
Yeah, go
Sir, I
ahead.
haven't seen the derivation yet for this equation, sir. So is it necessary to know the derivation of this equation?
See, so they will not ask you to derive this equation in the exam, okay? But anyway, so just see how to use it. That would be fine. So, but for your own knowledge, you can always learn how to derive it from scratch. Okay, but that will not be asked in the questions as far as I know.
Yes, sir. Thank you.
So now X trans C, this is X transpose. Let me just write it here once. Weight is equal to X transpose times X then inverse and then X transpose and then Y. Okay. Now let's define these two. So these will be X will be row vector and Y will be column vector. So that's what how would I know? See, we have to figure out the sizes of all these matrices. So we have two values. So weight will be a column vector of 2. Okay. So 2 rows, 1 column. Now here X transpose X, if X is a kind of row vector, then what will be its size? 5, uh, 1 cross 5, right? Now see, this is how you structure your data. So just see how I'm structuring it. Okay. So weight is what? Weight is basically my M and C. So I am representing weight to be this matrix M and C. That's my weight matrix. Okay. So it's a 2 cross 1 matrix. Now my X is a row matrix 1 cross 5. So that means X is equal to x1 dot x5. Okay. Now see how I will represent y. We will just follow this equation. Okay. So x transpose x, what will be this? This will be a 5 cross 5 matrix, right? Because x transpose will be a column vector and x is a row vector, so the output will be 5 times 5, so 5 cross 5 matrix. And then its inverse is same, so inverse up to inverse we have the same output, right? Now times x transpose t, that means this times what is x transpose? If it is a row, 5 cross 1, 5 cross 1. So the whole matrix, this whole matrix times y. I don't know what y is currently. Okay, so this whole thing would be 5 comma 1, 5 cross 1, right? And then so this will be only m.
So sorry to disturb again, but why is the equation different? Sir?
Which equation?
Yeah,
This equation?
yes, sir.
Is it different? Wait, let me just paste it.
No, sir. The equation where there was dot, in some places you have used cross. So
So let me just see it once. Wait. Yeah, so all of these things are your all of these things are your cross products. Okay. What is it? Yeah, all of these things are your cross products. And y
Y is 1 cross 5.
yeah, this is 1 cross 5 plus 5. Now the bias is missing, right? So we're just computing w at this point. I guess bias is represented as 1 in x. So we'll figure out it later on. 1 cross 1, 1 cross 1. Okay. So we'll do this. X is equal to np dot matrix. It's a row, so x2.
Excuse me, sir.
Yeah.
So how is y is equals to 1 comma 5, 1 cross 5?
1
Wouldn't
cross
it
5
be
means
resulting in 5 cross 5?
no, it's a row matrix. So these are the matrices, right? This is the 5 values of x and this is the 5 values of y. So we are representing them as a row matrix. That's why its shape is 1 cross 5. So we are computing weight w. Okay. Hey, wait once. Is this? Have I missed something? 5 plus 1. P transpose x inverse 5 plus 1. Wait, I'm making something. Okay. Okay. So we are missing something. Let me just find it. If I just multiply it over here, then it's a 1 cross 1. So you have to reorder the multiplication, okay? Me y is equal to this. Okay. Oh. X X transpose times y dot inverse times X transpose.
So this is what I asked, sir.
Wait, 1 minute.
Hello.
Yeah.
Sir,
So
can you represent the x as a column vector instead of row vector?
yeah. Wait 1 minute. 1 minute.
Then it will.
That's what I was saying. Yeah, I think if x is
let's
represented as a column vector, then it will work without reordering, sir.
okay. X is represented as a column vector, right?
Yeah, if you do that, because that is what it is in the formula.
Let me just write.
X should be 5 cross 1 matrix.
So let me write it in a more formal way. X1 M times X1 plus say M estimate plus C estimate is equal to Y estimate, right? Sorry, Y2, Y1. So this is what the equations look like actually. 1, 2, 3, 4, 5. So 2, 3, 4, 5. 2, 3, 4, 5. Okay. So if I represent X as a column vector and Y as a row vector, right? So X will be represented as a column vector. What is it? Dot T.
Sir, how long the class will continue today?
Okay.
How
It will
long the
continue.
class?
It'll continue up to 9, 10 maximum.
Okay.
So we'll try to approach this problem a bit. Y is equal to
And how
Y.
will we know which research scholar is like? How will we know when you are coming next time?
So it will be same for this Saturday class I will take.
Okay.
And the Friday class, I guess another person will take. Okay.
Okay. Okay.
Okay. So Y is equal to empty matrix chosen. This will go with the same matrix multiplication order. No. So we have to see with the order. With this. If this is 5 times 5, X transpose would be 1 times 5. No. They both of them have to be same. You have to reorder them. So y should be multiplied for this. Now this is what we computed as m. Okay. So the value of m is minus 0.99. It's very much erroneous with only 5 values. Okay, let's go with higher number of samples. Let's go with, let's say, 40 samples. Okay. Somewhere it's becoming a singular matrix. Choose less values. 30.
Actually, sir, the matrix multiplication is not commutative, right? So won't that be an issue if we take y on the left? Because the derivation is y on the right.
Yeah, but it actually depends on what is the shape of the matrix. So it's not commutative, I know, but if you cannot multiply if your shapes are different, right? So what was the problem? Singular matrix. So we are somehow it is becoming a singular matrix, so it cannot compute the inverse. Yeah, it's becoming a singular. So with 5 again. It's minus 160. So you see, okay, anyway, so I think I have to revisit this once, but it's giving us random values like minus 160, 0.99, something like this. I will revisit this and update this here. Um,
Sure.
Okay, so it will be
Sure.
something like it should kind of create a regression line which has less error than what we have, let's say, guessed right earlier. So it should have less error. That's what
Sure.
it should show. So okay, so I will revisit this, update this, and put this in the resources.
Sure, sir. And on the bias, why you have not considered the bias?
So the bias is actually considered. So bias will be considered as a one variable in the x. Okay. So I'll put them everything. I'll put everything here, and I guess shared with you in the resources.
No, I was
So it's
talking about
actually,
that beta zero, right? The bias.
yeah,
It
exactly
is
the
not
beta.
in.
Yeah, the beta zero will be considered as a one parameter, one constant parameter in x. So that we have to also account for later on. So beta zero will be there. So I will put everything here and let's say share with you. So I currently am a bit confused how this matrix multiplication is turned out to be minus 163. I'll revisit this once. Okay, I'll revisit this concept once and put everything here.
Okay. But you are saying that the beta zero will be the part of x itself. That is what you are saying.
Yeah. It's no, not as a part of x. It will be part of x as a constant variable one. Okay, so that one will be responsible for computing beta zero. Okay, so I'll probably mention it here and share with you the notes. Okay,
Okay.
we'll just revisit this once. I'll share the logic in the WhatsApp group as well. But
Sure.
currently I'm a
Sure.
bit confused, so let's not go into this. Let's
That's
just leave it
okay.
here. Okay. So now, what was our goal is to compute this beta matrix from let's say two parameters will be there for this, right? Because beta 1 will be representing this m and beta 0 will be representing the constant term b or bias, which we expect to be a little bit less erroneous than whatever our guess was earlier, right? So anyways, we'll put that derivation and share with you that resource. See. Okay, so that's what regression means. So anyway, this equation I'm a bit confused now. We'll revisit this once. So let's say for sake of understanding, let's say the beta matrix comes to be m equal to or m estimate is equal to 0.49, okay, and c estimate comes down to, let's say,
Sorry, sir. I'm
1.87.
asking that question again. But C estimate will be the part of W itself, or you are going to do?
Exactly. So
Okay.
this is actually beta
Yeah.
1, and this is
And this
actually
beta
beta
zero.
0. Exactly.
So dimension of W should also change, right? That's what I was saying. It is 1 cross
Yeah,
1. This
dimension. dimension of W should be
1 cross 2.
1 cross 2 or 2 cross 1, something like this.
Yeah,
Okay,
okay,
so
sure.
I'll revisit this once and update it here
Okay.
after the class. Okay. Okay. So let's assume these are two values computed from the equation, and okay, and the resultant graph would be looking like this.
Okay.
Computed, and you have x and y estimate you compute. I estimate computed would be x times m estimate times x plus c estimate.
And sir, in the exam, say for example, some other problem is there for which we need to do matrix inverse and all, right? Can we quickly write Python code and do the inverse of the matrix to save
No,
time?
see, so to write inversion code in like pure Python is like horrible. Okay, so you cannot do that in exam. So if you are asked to compute a matrix inverse, you will be allowed to use NumPy library. Okay, most of the time
Okay,
you
so
will be allowed
NumPy
to use
library I will be able to use in the TCS
yeah,
on coding.
yeah. So
Okay, okay.
if they ask you to compute inverse, or let's say
Yeah.
transpose is easy to do in Python, but inverse is pretty hard. Okay, so you have
No,
to
but the reason I'll tell you is because there is one assignment question, right? Which needs me to calculate inverse. Basically, it tries to estimate the beta parameters in the assignment question. So
okay.
doing this in exam without a scientific calculator is going to be a nightmare. So instead
Yeah,
of that,
exactly.
can we do that? Can we write a Python code and then select the option?
Most probably. So see, so I guess without a scientific calculator, so with the tool that is available here, right? This one, you can do it, but it will take a lot of time.
Correct.
Okay, so if you are asked as an MCQ, I think then you cannot run a Python code. Okay, so if it is asked as a MCQ, they will ensure that the matrix is not too big. So it will be a, let's say, a 3
Okay.
cross 3 matrix, right? 3 cross 3, that will be the highest order you will see. So 3 cross 3, you can just quickly compute 2 cross 2 adjoints and get the matrix inverse, right? That will be easy to do
Yeah.
in this calculator as well.
Sure.
Okay.
Sure. But Python free access will not be available in the exam.
No,
Like I
no,
Oh,
no,
okay.
no.
Okay.
So you'll see that your screen only have this TCS Ion exam platform, and you don't have access to any terminal or ID or anything. Okay, so whenever there is a programming question, they will have an ID uh, within that platform itself.
Okay. Got it.
Okay. Uh, So yeah, so this is what we are supposed to get, but anyway, there is some issue with this code. I'll revisit this. So the resultant computed M and C would look something like this. So this is what that equation x transpose x inverse x transpose y, that equation does. Okay, it computes the beta parameters from the sample of data points. Okay. Okay. So I guess we can. Yeah, because it's already closed 9:07. You can close it, close the
Yes,
call.
sir. One more request. When you are
Yeah.
doing the zip of the assignments, can you? Is it possible for you to give the last year question papers also?
Last year question paper, see, because it's a computer-based test, right? So last year question papers will not be available with us. Okay. So,
Okay.
so we have to kind of do similar problems as assignments. So assignments have lot of kind of code snippets, MCQs and all. So you can do similar type of like other similar type of questions, like apart
Okay.
from the assignments too. That would cover your overall kind of coding practice that you would do for the exam. Okay.
Sure. Sure. And if you could just reminder as I talk to other research scholars to put their content also here, that will help.
Okay. Okay. So the other person who is taking the class, right? So yeah.
Sure.
So I'll
Yeah.
communicate with you and
Okay. All right.
ask him to put the things here.
Sir, can
Yeah,
you
go
please
ahead.
revisit
I have one
this
question.
problem in the next class, sir?
Yeah, so from the next class we'll be let's say looking into concepts related to that particular week's assignment. So from next class we'll be looking into week 1 and week 2's assignments. Okay. So if
So can
week
you
2
also
is
do a problem similar to the one you did today?
exactly. So we'll see for the particular concept that we'll be talking about, we'll see its related problems as well as cover the assignments. That's the whole idea of this live sessions. Okay, this was just an introductory class, just to let you familiarize with the coding environment, the approach we'll be taking. From next class onwards, we'll be kind of digging more into assignments and the application of the theory that you are learning in the class. Okay.
Hello. Hello, sir.
Yeah, go ahead.
Hello.
Yeah, go ahead.
How to calculate the how to calculate variance of this linear regression?
Yeah, variance. See, bias means how much off you are in terms of y-intercept. Okay, and variance, you cannot compute variance directly from the prediction. Okay, so you can always compute variance by this formula, normal variance formula, but variance in terms of concept means that how varied you are from the actual value. Okay, so you can let's say for a mathematical understanding you can do estimate. So variance formula is what uh, uh, so computed, this is the computed value and this is y, 2y, right? So this is true y and this is y. Okay, now bias means, wait, let me just put it in another cell so that you can see. Bias means how much off you are in terms of y-intercept. For example, here you can see the y-intercept is very close, so the bias is not that much big. And variance means over time how much far you are off from all the values. Okay, and how varied you are, how varying you are. Okay, so for example, in this case, it's completely a bias problem. It's not varying too much. It's kind of consistently following the ground truth. Okay. So for computing variance, there is like no direct method, but to understand pictorially, you can assume that, okay, how much far you are off from the y-axis intersect, that is the bias, and how much varying you are with respect to the ground truth, that is the variance. Okay. So to compute it, you can think of it as this. So this is the error, right? This is the error in all the points. So the variance of this, you can think of it as a variance of this. Okay, and bias is the mean error you are getting. You are mean. So this is the bias, and this is the variance of the error. Okay. So the difference, the error, how much it is varying, and what is the constant error you are getting. That the constant error is the bias part, and the how much variance you are getting, that is the variance part. Okay.
Sir, where will the recording of this session will be available?
It will be available in YouTube. So I'll share you the link in the
Sir?
WhatsApp group. Yeah.
Okay.
Go ahead.
How many live sessions will we be having in a month?
It will be every week you'll have one session.
Okay, and this session was for which week, sir?
It was for week 1, so it's the introductory session. Okay, just to
Okay, sir.
plan what we will be doing next and what are the coding environments we'll be using. That's it. So this week's idea was to get you familiar with how we'll be handling live coding sessions and all. That's it. Okay, from next week we'll be focusing on assignments and what are the applications of the theory that you are learning.
Okay, sir. Thank you, sir.
Sir, can you also update the bias and variance within that same code where you are updating?
Yeah. So I'll update this part, okay, and this part together and share it with you.
Sure.
Hello?
Okay, so I guess we are.
Hello?
Yeah. Anybody have any questions?
I have another question. So
Yeah. Go
can
ahead.
we can I use SQL and libraries directly? SQL
So
and
see,
libraries.
SQL you can use to kind of uh, like you will not be able to use SQL
For
in the
for
exam.
for oh,
Okay, so SQL basically gives you
okay.
this estimators like already pre-built estimators like linear regression, logistic regression and all. But expect that in your
Yes.
coding questions, you can only use NumPy.
Mm,
Uh, Nothing will be available
okay.
apart from NumPy because matrix multiplication and all, there is no point of asking a student do it in Python from scratch. Okay, so you can use the library NumPy. Try to implement all the classifiers and everything with NumPy itself. Okay, so that in the code
Okay. Sir.
in the exam, if you are supposed to implement a linear regression model, you can just do it with NumPy. Okay.
Okay. Thank you.
So just for a quick reminder, just join the WhatsApp group if you are not already joined.
Sir,
Yeah.
So in the exam, they may
sir,
ask like,
did you
go on.
share the Jupyter notebook in the WhatsApp group, sir?
What was? Repeat the question once.
The Jupyter notebook notes, will you share it in the group, sir?
Yeah.
So, sir, in exam, any model can come to implement with NumPy?
We will share it with you. So all the code.
Hello?
Yeah, go ahead.
Sir, in the exam, any model can come and they may say write that model using NumPy, is it? Or
For example, not every model, right? There's a time bound on this, right? So they may ask you to, like, for example, they give some like small two arrays x and y. Ask you to estimate the beta coefficients, something like
okay,
this. Okay, so you will
okay,
be able to kind of memorize the formula and implement it in NumPy or some mathematical library.
sure.
Yeah. Okay.
Okay.
So we'll share the resources in WhatsApp as well as this sheet. You can follow this sheet too for the YouTube links. Okay. And the present the resources will be shared on the drive too. I'll put everything together in a kind of well documented form and I will share it in the WhatsApp. Okay.
Okay.
Okay. So we'll close the call
Sir,
now. Yeah. Go
yes,
ahead.
sir. Last question.
Go ahead.
Sir, to practice, like you elaborated, demonstrated, we also need to practice these things. So, which software we should download? That Jupyter.
Yeah, so you can use Jupyter on any ID. You can use it in VS Code as well. Okay, but what Jupyter lets you do is to see intermediate outputs. Okay, so even so, for example, if you're confused to how to let's say approach a problem, you can start with it, see intermediate outputs, then based on that design your like other like algorithm from there. Okay. So it's
Yes, yes.
for the students, it is better to whenever you're approaching a data science problem, it's better to use a notebook. Okay. But if
Yes.
you are, let's say, writing production code or you are writing in your exams, then you will not be accessing this notebook, okay, anymore. So it will be kind of a Python IDE itself. For example, VS Code or the Python IDE, VS IDE, right? So this is
So,
just
but
to
right now,
learn. This is just to
yes, sir,
learn.
for learning
Okay.
purpose, Jupyter is very good. Okay, for the
Yeah.
learning purpose.
Yeah. Exactly.
Yes, sir. I want to install this Jupyter. So first I
Yeah.
have to install Anaconda, na? Then it will.
You can directly so if you have pip, you can directly write pip install notebook. That would also install it. So if you have a Windows machine, right, and you have pip install,
Yes.
you can just use pip
Okay.
install notebook.
Okay,
This
sir.
should work. Or if you have a Linux machine, also this would work. But yeah, if you want to use Anaconda, you can use it. You can download Anaconda. So Jupyter Notebook comes bundled with Anaconda. Okay.
Okay, sir.
Sir, the coding questions or whatever, I mean, it will be more or less similar to what is there in assignment, or the
Uh,
scope will be.
No. It will be similar. So
Okay, okay.
it will be
So
similar
we
to
will
what
get
we
an
do.
idea. If we solve the assignments, we'll get an idea what kind of coding
Yeah,
question will also come. Okay,
exactly.
okay.
Exactly. Okay. Okay. So, any other question, guys? Okay. So I think
Notes, sir,
notes
will
I
be
will share. I'll share in the WhatsApp.
for the lecture videos notes.
Everything. So, like whatever we will be learning in these sessions, I will share the notes in the WhatsApp group with you. Okay. So just join that WhatsApp group.
And one
Okay, sir.
more thing, sir.
Mm-hmm.
Hello?
Yeah, go ahead.
Hello?
Go ahead. Yeah, go ahead. I can hear
Yeah,
you.
yeah. That is examination point of view. MCQs are there or theory part of there?
No. MCQs will be there mostly. Okay. So
There
there
is
will
no
be
theory part. There
no
is no
it so
theory part.
so it's a computer-based test, right? So there is no elaborative answers that you can do. So anything that will be mostly MCQs or multiple select questions like this. Okay.
Okay, thank you,
Multiple
sir.
choice questions will be like the major part. And we'll see the in the assignments too, right? The assignments are also MCQs.
Yeah. Okay,
So
thank you, sir. Yeah, thank you, sir.
okay,
Sir,
and
while going through the videos, like
mhm.
week one, week two content, what is more beneficial? Should we make our own notes, or some notes is already prepared by NPTEL? We can directly read
Uh,
from there.
So I will check with them once. I will check with the coordinators that whether they have some notes available with them. But it should be like the notes should be prepared from your side too. That okay, the video lectures are there. You can just note down whatever you understand from the videos. Okay, it will be the best resource that you can use it before your like exam date. Okay, which is prepared by you will
Oh,
be
yes.
most remembered by you. Okay.
So,
Oh, yes, yes.
so how come the week one and week two assignment submission date is same?
That I don't know. I have to check. So see, there are two types of TA in a NPTEL course. Okay, there is regular TA who sets the assignments, and PMRF TAs as us who takes these live classes of solving the assignments, revisiting theories, and let's say giving further notes and resources. Right. So I have to check with them, or you can just mail in the channel too. Okay, that okay how this the assignment dates are still. They will kind of solve this. Okay, the regular TAs will solve this.
Okay, sir. Thank you.
Sir, hello.
Yeah, go ahead.
Actually, when we are practicing the questions, we can use the Jupyter Lab as you said.
Yeah,
But
yeah.
when we are writing the questions, if Jupyter Lab is not there, how can we give the answers by solving the questions? Is there, should we use VS Code on the time, or else whether the questions is based on the prediction that is like code debugging, or what is the basis of questions will be for the coding related questions?
So it
How
will
we
be
can give
kind.
the answers for that?
Yeah. So see, you have to also for Jupyter Notebook, you can see intermediate outputs, right? So it is
Yeah.
just to practice. It is just to practice, but
Okay.
it is so in coding questions, there will be a kind of Python IDE, generic Python IDE that you can use. Okay, so expect that there
So
will be no autocomplete, there will be no suggestions, there will be no intermediate outputs. You have to write the entire code, then only you will get the output by running it. Okay.
in the Jupyter Lab also we are not having any auto suggestions now, sir. Sir, so during the exams, can't we use the Jupyter Lab or Jupyter
No,
Notebook?
no. It's not integrated with that examination platform.
So
Sir, can
parallel,
we go?
okay, parallelly while we are solving the questions itself, we can use the Python IDE in the same
Yeah,
system to give the answers on that.
yeah, yeah. So see, try to practice as much as you can. Jupyter Notebook is nothing but a tool to give you intermediate outputs. You can do the same thing with the Python normal VS Code IDE by putting up print statements.
Okay.
Okay, but
Okay.
Jupyter Notebook is easy to handle when you are trying to learn something. Okay, you don't have to run it multiple times. You can kind of assume that the values are persistent among multiple cells. So if you have defined A somewhere at the top, you can kind of use the A at somewhere at the 10th cell, okay? But for
Sir, so for practicing for the examination, it is advised to use VS Studio, sir.
yeah, can you please repeat? I didn't get your question.
Sir, so for practicing for the examination, it is advised to use VS, sir, rather than Jupyter.
No. So you cannot use Jupyter Notebook in the exam. That's what I'm saying. You can only use it for practice.
Sir, is there a way by which we can experience that exam environment before going to exam? Is there some way by which we can do that?
I'll check. I'll check this. I will keep a note.
Yeah, I think all this question will get solved then, right? Like if we can use
yeah.
that real calculator in the exam and real Python editor in the exam, it will if we can experience that now, it will be very good.
Okay. So I'll check that. I'll check that and let you know.
Sure.
And one more question, sir. Attendance is necessary, sir? Compulsory? Is it compulsory?
It is. See, it is not necessary from our end, okay? But
Knowledge
obviously,
purpose.
see, we will be discussing. So the TS will be discussing assignments, solve your doubts, and let's say give like additional resources to study, right? So these things will be kind of so it's like with the only lecture materials, it is hard to kind of perform well in the exam, okay? So you have to kind of keep on practicing, solving your doubts and everything. So if you think that these live sessions are beneficial to you, it revisits your theory concept, it discuss the assignments, as well as kind of gives you a kind of application of the theories that you are learning. It is better to attend. So from my last experience with this computing with Python course, all my students they are very happy with the overall 12 weeks live sessions. Okay. So if you are finding value in the sessions, attend it. Like it will eventually help in your exam. So you will be known to all the questions. You will be known to, let's say, many concepts that are, let's say, theory not discussed in the theory classes. So that you can like, yeah, that's the whole point. So if you get value from this, you attend it.
Okay, thank you.
Okay. So. Okay, so like I would like really like to thank you all guys for waiting for 1.5 hours. Okay, that much of patience even I don't have. Okay, so so just know that I was stuck in traffic. So it will not happen from the next class. Okay.
I think it was worth waiting. So thank you so much for a very good session.
Okay.
Thank you very much, sir.
So I'll put
Yes, sir.
everything
Thank you
in
very much, sir.
chat. Okay. Thank you.
Thank you
when would
very
be the
much,
next
sir. It
session?
was a very wonderful session. Thank you. Worth waiting for such a long time.
Thank you guys.
Thank you, sir.
Really mean a lot.
Thank you, sir. Thank you.
Thank you very much, sir. Sir,
Thank
when
you
would be
very
the
much.
next session?
Thank you very much, sir.
Yeah, so that the next session would be Saturday same time, 6 to 8.
Okay,
6
sir.
to 8. Every week one
Thank you,
session,
sir.
right?
Yes, I would suggest put a calendar invitation in your Saturday 6 to 8 slot. It will kind of remind you to join the session and put this week's this meeting's link in that invite. That okay, okay, you have to join this link. Okay.
Yes, so every week one session will be taken by
every
you.
week one session will be there. We'll next week let's just make it clear. Next week we'll discuss the week ones and week twos learning materials, and we'll try to see like whatever assignment questions are there. Okay.
Yeah, yes, sir.
Okay.
Thank you, sir. Thank you so much.
Okay.
Thank you very much, sir.
Thank you. Bye. See you guys.